Hi everyone. In the given problem, we have to find the factorial of a given number and then calculate the number of trailing zeros. Let us take this example of 5 factorial. So the 5 factorial would be 5 into 4, 5 into 4 into 3 into 2 into 1, which is going to be 120. And it has one trailing zero, so we are going to return 1. So one way of solving the problem, we can find the factorial of a given number and then we can calculate the trailing zero. So it would be a very easy way of doing it. But because it's a medium problem, and I think if you do it in that way, I think the program is going to run properly. So I can create a function definition where I can just get the factorial and can count the trailing zeros that can be done. But can I solve this into a logarithmic time complexity? So now to do it right, we have to find some pattern out here. So let's say, what is the value of 1 factorial? So 1 factorial will be 1, 2 factorial would be 2, 3 factorial would be 6, 4 would be 24, and 5 would be 120. Similarly, if I go out right till 10 factorial, right, if I'm not wrong, it is 3, 6, 880, something like that, a big value. I just could not recall the exact number. You can check it out, but it's going to have 2 zeros out here. So we can keep on going it right, and we would be able to find a pattern. So pattern is that after every 5, right, the number of zeros are increasing. So easy way of finding it out, right, would be if I get a 5, then just the number keeps on increasing. So 10 has, right, 1 5 value out here. So because if I multiply 10, right, I'm going to get 1 5. It would be 10 into 9 into something like that, and I'm getting 1 5. Similarly, that could be another way. Okay. So if I have to say, right, what would be the factorial, right? 1 cross 2 cross 3 cross till n. Okay. So the factorial would be n by 5 plus n by 25 plus n by 125, because the 25, right, had 2 multiplies of 5. Similarly, 125, right, would have 3 multiply of 5. So whenever the number 125 would come, right, so you have to calculate in this way till n by some value, like some factorial of n. So you're going to get in that fashion. So you have to find a pattern, and we have now established a pattern out here. So how can we write the code? So I can create a result value which is going to be 0. Then I can create a I value which is initially 5. So while my I is less than the given value of n, I can say result equal to result plus n divided by I, and then I am going to equal to I multiplied by 5, because I'm going to take the multiple of 5, and I can say return the result. Let us take the example of 10. Okay. So initially, right, I is 5 and result is 0. Now I am in this loop. So the result would be 0 plus 10 double divided by 5 would be 2. So the result is 2, and then I would become 5 into 5. It would become 25, which is going to be the greater. So loop will execute and the result would be 2. Similarly, in case, right, the n value is, let's say, 26, 6 for some reason. So initially, right, the result would be 0 plus 26 by 5 double divide by, so it would be giving a value of 5. So the result is 5 for now. Then I would be become 5 into 5, which is going to become 25. 25 is still less than n. It would be less than equal to n. So in that case, right, again, the result would be 5 plus 26 divided by 25, which would become 6. So our result is going to return 6. So here, right, the way of solving the problem, because it's not very intuitive, right, we have to find a pattern in the factorial and then we are able to calculate the zeros. So it's not very intuitive. You can go with the normal way of getting the entire result, and once you got the result, right, you can just count the trailing zeros. But to increase your time complexity, right, to increase your efficiency, you can go also by finding a pattern, which would be a little bit less intuitive method. Now let me jump to the Python solution. So the first thing that we're going to do, right, we are going to have our result, which is going to be 0. I is going to be 5. So while I is less than equal to n, in that case result equal to result plus n divided by I, and then we're going to increment the I by I multiplied by 5, and we are going to return the result, and it is going to give us a logarithmic time complexity. Let me run it. As you could see, the public test case is passed successfully. Let me submit the code. Code got submitted successfully and it is beating 100% of the submission. So it's pretty efficient. It's a basically logarithmic time complexity. That's all for this video. See you in the next one.